Hi guys, in this video, let's learn a bit more about some special cases. So special cases that I want to mention with by parts today are number one, integral square root of x square minus a square dx. So what will be this integral? Now let's take, in this case, let's take I as integral square root of x square minus a square into 1, constant 1. Since I just have square root of x square minus a square, I can say that, it's getting multiplied to some constant 1, right? Now, let's take 1 as your second function. Let's take this as the second function, and let's take this as the first function. So this would mean that I is equal to first function as it is, that is square root of x square minus a square as it is, into integral of second, which means into x, integral of 1 is just x, minus whole integral of derivative of the first. So derivative of the first would be 1 upon square root of x square minus a square, and chain rule will play its role, so getting multiplied by 2x, into integral of the second, which is just x, and integral of this entire thing, right? So which means, what do I have here? Which means, what do I get here is square root of, so it's x into square root of x square minus a square, minus 2 cancels here, and what do you get is integral x square upon square root of x square minus a square dx, right? That's what we get, right? Now what I'm going to do here is I'm going to play a trick, and that's going to be on this integral, the second one. So this is clear. This is x into square root of x square minus a square minus whole integral x square minus a square plus a square. I'm going to add and subtract a square, and I have square root of x square minus a square here. So this gives me x, of course dx here, x into square root of x square minus a square minus, so you have x square minus a square. You can just break it up, of course. So you can break it up as x square minus a square in one integral divided by square root of x square minus a square. So if you divide, the whole thing with its square root, then of course the square of that will be, a square root will be left in the numerator. Or in other words, what I'm trying to say is that let's just break it up. So you have x square minus a square upon square root x square minus a square dx. And then you have plus a square, but you have a minus sign outside in this integral. So it's going to be minus a square upon square root of x square minus a square dx. So, which means that what I'm left with, this is I, is equal to x into square root of x square minus a square minus integral of square root of x square minus a square dx minus a square integral dx upon square root of x square minus a square. So clearly what you can see here, this is nothing but I. This is nothing but I itself, right? So you can take it this side, since that's nothing but I. So you can say that 2 times I is equal to x square root of x square minus a square minus a square times integral of 1 upon x square minus a square. Now, looks like we've seen this somewhere, right? Integral dx upon square root of x square minus a square. Yes, we have seen that. We have solved it. And what I'm going to get here is the following. Try to recall. So you have a square as it is. And this integral gives you 1 upon 2. So a square upon 2 log of mod x plus square root of x square minus a square plus c plus c. So which means, sorry, not 1 upon 2, not right now. I've not taken 2 down here. So it's going to be log x plus square root of x square minus a square plus c. So this is twice of I. So what does it tell you about I? This means I is equal to x upon 2. Now you will have this 2 in the denominator. Minus a square upon 2 log mod x plus square root of x square minus a square plus c. And that's going to be the correct answer. In fact, if you take up the task of figuring out the integral of similar kinds, square root of x square plus a square, using the same tactic, using the same things, you will be able to figure out that this will turn out to be. So you know what you will do? You will take this as first and 1 as second, and you will be able to figure out that ultimately your I will turn out to be half of under root of a square plus x square plus, this time you'll have a plus instead of minus, plus a square upon 2 log mod x plus square root of x square plus a square plus c. I can give you hints if you wish to. So what you will do, you will use by parts. So I will be equal to first as it is. So I'm going to answer the question how. First as it is. So square root of x square plus a square as it is into the integral of second. So into x minus whole integral derivative of the first. Derivative of the first is 1 upon twice of x square plus a square into 2x into x plus c. So plus c is something that I generally write in the end. So let me not write it right now. Dx. So you will clearly integrate it. How will you do that? The fact, the manipulation that you will use here. So you have x into square root of x squared plus a square this time, minus whole integral, 2 cancels, you have x square, you will add and subtract a square minus a square upon square root of x square plus a square dx. And hence what will happen, this as it is, here it will be square integral of square root of x square plus a square dx. So let me just write it down completely for you. And maybe I can give you the next one as an exercise. So this, now minus will give you plus a square. Integral 1 upon square root of x square plus a square dx, right? So what will you get? This is nothing but I. So this is nothing but I. So you'll have twice of I is equal to x square root of x square plus a square times this integral again Can you recall? You've seen it with me only. Integral 1 upon square root of x square plus a square. This will give you log modulus x plus square root of x square plus a square plus c. And since you have 2 times I, so I will be x by 2 square root of x square plus a square plus a square by 2 log mod x plus square root of x square plus a square plus c, right? So this is what you will get. And similarly, you can work out with square root of a square minus x square dx. Now again, if I is equal to this integral, then you can take this as 1 and you can take 1 as 2 and you can again work it out. But this time you will have a different integral because in the denominator you'll have square root of a square minus x square. So let's see what you get. So here you will have I is equal to, first as it is, that is a square minus x square as it is, integral of 1 minus integral of whole. So you have 1 upon square root of a square minus x square into minus 2x into x dx. So this will give you a square minus x square into x minus minus plus integral. So sorry, there is a 2 here. So 2 cancels. And it's going to be x square root of a square minus x square dx. Or I could have kept, or maybe what I can do is I can just keep, let's just keep this here and we have minus x square inside. Why? Because I have a square minus x square in the denominator. So let me keep minus x square there. So a square minus x square minus. Now, what is the manipulation we will use? We will add and subtract a square. Square root of a square minus x square. So this will give us x square root of a square minus x square minus, let's break the integral. So you will have integral square root of a square minus x square dx. Oh, don't forget to write dx here. Now minus minus will make it plus. So a square outside and you have 1 or dx upon square root of a square minus x square. Now this you know is I. This you know is I. And I is equal to this entire thing. So that means twice of I is equal to x square root of a square minus x square plus a square integral of dx upon square root of a square minus x square. So which means what do we have? We have this is equal to x into a square minus x square. Do you remember this integral? We've done it together. Integral 1 upon square root of a square minus x square is the integral of sine inverse x by a. So you got to get sine inverse x by a here plus c. And or plus c is something that you can write it down later on also once you have divided all. So I will be equal to x upon 2 square root of a square minus x square plus a square by 2 sine inverse x upon a plus c. So that's what you will get here. Now let's apply this concept on a couple of examples. So suppose we have to integrate. So I is equal to integral square root of x squared plus 2x plus 5. So if that is the integral we're looking at, which means that we are looking at the integral of square root of, what I'm going to do here is, the trick that I'm going to use here is to create whole square. So I can say that this is, since you have x squared plus 2x, so you can just add and subtract 1. So add and subtract 1 plus 5 dx. And this will give you integral of square root of, clearly can you see, you got to have, you have here x plus 1 whole square and minus 1 plus 5, that gives you plus 4 dx, which means you actually have your integral, x plus 1 whole square plus 2 square dx, which means like x square square root of x square plus a square dx, right? Integral of that. We already know what this integral will turn out to be. We have solved it. And this integral will turn out to be 1 upon 2. The x that you have is 1 plus x into the square root of x squared plus 2x plus 5 plus 2 times log, that is basically a square is 2 square upon 2 log mod x plus 1 plus square root of x square plus 2x plus 5. Whole thing plus c. Now, why was I able to directly actually write in terms of x plus 1 is, even if you know you would take a transformation, if you will take say x plus 1 as some y, you will have dx equal to dy and nothing will actually change. So that is why I could actually directly also write it. In case you know there is some some sort of change, then please take that into consideration while transforming. Then you must transform it properly and do it. Right now also you can do so. I've done it directly only because I took the liberty of the fact that x plus 1, if I take x plus 1 equals to y, then dx is equal to dy and nothing will change in my integral. So that is why I directly wrote it in terms of x. Let's take another example here. So let's take an example where my I, the one that I have to integrate, is integral square root of 3 minus 2x minus x squared. So if that is the case, again, we can create whole square. I can see that we can create whole square here. And since I have minus 2x minus x squared, so keeping 3 here as it is, minus 2x minus x squared minus 1 plus 1. So what I'm going to do is I'm going to collect this in the sense, I'm going to write it as square root of 3 minus common. So this is x squared plus 2x plus 1 outside, which implies that what do I have here? This is the integral of square root of, now 3 plus 1 gives you 4 minus, what do you have here? It's x plus 1 whole square, right? So you have 4 minus x plus 1 whole square. 4 minus x plus 1 whole square. So 4 minus x plus 1 whole square is a square minus x square case. So a square minus x square case, again, so this time I will expand it for you. So let's take x plus 1 equals to y. So dx equals to dy. And this whole expression I will look like integral of square root of 4, which is 2 square. Let me just write it as 2 square minus y square dy. Dx dy is the same thing. So that is why. we have just solved it. What will I get? This integral will be equal to 1 by 2 y square root of 4 minus y square plus 4 by 2 a square by 2 sine inverse y by 2 plus c. Or in other words, now substitute back. So you'll have half y is x plus 1 square root of 4 minus x plus 1 whole square, which actually when you will open it up, what will you get? Do I really need to write 4 minus x plus 1 whole square? 4 minus x plus 1 whole square is nothing but the original, square root that you had. So which is basically 3 minus 2x minus x square. So I can write that down. Plus 2 times sine inverse x plus 1 upon 2 whole thing plus c. That's the application of these special cases.